Greetings, ninth grade honors science scholars. We're going to be doing the Conservation of Energy Lab. No, not the Conservation of Energy Lab. I've got the wrong one in front of me. We're going to be doing the Kinetic and Potential Energy Lab. So, that would be this one that I have over here. All right, so procedure for part one. We're going to be changing the ramp height and making it higher. You can see that I've got a mark right there for the next height. But I'm just going to show you what it looks like. And then we can, oh, that picture that I'm seeing on my screen looks terrible. It's not even in focus. I didn't want to do that. Okay, let's get that focused in. That looks a little bit better. Okay, so we've got a ramp and we're going to set it at various heights and we will measure how far the Cool Whip container moves. So here is our first trial. Oh my goodness, was that exciting. Now we switch it and we change the height. And I'm suspecting there might be a little bit more energy to move the pie pan. Not pie pan, but Cool Whip container. Oh, look at that. I don't know that you can see it, but it did go farther. This yellow mark is the starting point, and if I was actually measuring the data, I've got the meter stick along here that I can measure the data. Now we go to the third height, which is right here. There is our 30 centimeter mark, and what's really cool is I can hear the marble, actually the ball bearing, hitting the Cool Whip container. And I'm looking at the screen and the thing is not moving. So there's a little bit of lag. All right, so that's the general trend in the first data table. I'll give you the data in a bit, but basically it looked like the higher the ramp height, the farther the Cool Whip container moved. Okay, now we are using 3 different massed ball bearings. This one is the low mass. This one is the medium mass. And finally, this third one will be the large mass. We're not going to record their masses. We just have low, medium, and high. All right, let me get the Cool Whip container centered. And then here is our low. Whoa, did you see that? That was such an exciting result. Okay, there was our low mass. Didn't go very far, pretty much just tipped over the container. Here's our medium. Oh, it missed. Our Cool Whip container did not cooperate. So let's get it to actually cooperate. Looks like that one went a little bit farther. And finally, our large mass. That went pretty dang far, almost fell off the table, went all the way over to the edge. Now, you guys get to the third data table. And the third data table involves the launcher and there's a spring action here. Let me just show you that there's a plunger that is all the way back in here now. And when I release this, watch how quickly the plunger shoots out. It's actually pretty powerful. That's neat. So I'm going to set it flat. And we are going to change the spring setting from 1 to 2 to 3. And so I'm going to set it on spring setting number 1. And there's our Cool Whip container. And now I will release. And it shoots the ball down there and it moves the container. Let's see what setting number 2 does. Went pretty far. And now the third setting. In other words, it's all the way back now. And we'll watch this one. That was neat. It probably would go beyond the length of the lab bench. Okay, so there's our third data table. Now finally our fourth data table. We're trying to keep the velocity roughly equal, and then we'll try our different mass marbles and see what happens when we have a different mass with roughly the same speed. So here is our first marble, the low mass marble. That went pretty far. That was pretty neat. And now we'll do the medium mass marble. And what that Cool Whip container wants to be right about there. All right, so now we try our medium mass marble. And that looks like it went a little bit farther. And now finally, we have our large mass. And so here we go with the large mass. And that looked like it went even farther. How exciting was that? Now let's get some data. All right, let's look at some data now. Let's actually punch some data in here. Here's our average distances. And this is some data that use different types of marbles. And so the data isn't quite as it's not as big of a difference between the subjects or between the ramp heights. 5.2 for 10, 6.8 for 20, and then 8.7 for the 30 centimeter. Okay, there's our first data table, 5.2, 6.8, and then finally 8.7. Now we go to part 2. Our average distance for the low mass marble is 3.1 centimeters. For our medium mass was 5.4. And now finally, for the high one, we get 11.6. And now our third data table. We set it flat and we used the different spring settings. And we've got spring setting 1, 2, and 3. And our distance for traveling is 2.6. And again, this data is not reflective of the data that we saw because we're using different containers. When I use this data, we were using different ball bearings. 2.6, 3.9, and 5.9. And now finally for the last data table, the hopefully equal velocity with different masses. We get 3.7. And then 5.4 for the medium mass ball bearing. And then for the large ball bearing, it was 8.9. And there you go. There is the data that you can use for all of the labs. So now, about all you have to do is answer like two to four questions for each part. So, analysis questions for part 1, there's 4 of them. For part 2, there's 2 of them. Part 3, there's again 4. And finally, for the part 4, there's just 2 questions. Good luck. Get this done, and I will see you later.